by reducing the friction, less energy is wasted. So whatever energy is here will basically continue, all right, converting from kinetic to gravitational to kinetic to gravitational now, and that would give it enough, all right, for it to pass the 360 loop. Okay, so once again, you have to learn and understand how energy works. Okay, let's try a different demonstration. What if this hill at the second point was lower? What do you think would happen? Let's try it out. Danger. So what does the second hill do? It basically provides a kind of a, you know, excitement for the people on the roller coaster. Okay, but it also provides a kind of a, you know, a kind of a support or a soft landing, right? As it goes up, it comes back down to prepare it for the very last loop. Okay, if you increase the second one all the way up, let's see what will happen. See, it's very hard for the cart to move over. Why? Because this height of the second loop is much higher, okay, or just slightly higher than the very first hill. So the amount of energy required for the car to move up and pass down wasn't enough, because this height was slightly higher than this first hill. So let's reduce it a little bit and see what happens now. Okay, oh, it goes through, very good. And yes, that's a successful. So what we are doing here is demonstrating the principle of conservation of energy, where energy at the start, okay, is conserved throughout the whole motion, and conversion of one form of energy, in this case gravitational potential energy, to kinetic energy, and back to gravitational, and back to kinetic energy, and back to gravitational, and successfully designing a roller coaster course. Alright, let's move on to our lesson.
That energy makes things move.
Energy makes things go.
Makes things move. Energy makes things move.
Howdy, folks.
Okay, now from the video you learned that energy makes things move. Alright, but I want to emphasize the point that energy it has a proper definition. Alright, and I want to bring it back to you here. The definition of energy is the ability to do work. Alright, the video said make things move. That isn't the official definition. Energy is the ability to do work.
Kinetic, your host, and I'm here with the ever-energetic Violet Light. You all know the rules. We spin the wheel of energy, and we change one type of energy into another type. Okay, Violet, convert some chemical energy into kinetic energy and give the wheel a spin! Now, that's what I call sound energy.
I think you can see why we call him Mr. Sound Energy. He's like that all day long, aren't you, Jerry?
We're just going to go. We're not going to rehearse. Good. Love it. Okay, here we go. Here we go. Right now, this bowling ball has energy. It's not moving, but it's got energy. Please consider the following. You ready? 3, 2, 1. It looked like it was going to smack me right in the head, didn't it? I mean, it's a bowling ball. It would knock me pretty good. But it'll never hit you in the head. Because when we pulled the bowling ball back from the middle, we gave it potential energy. When we let go of it, it had kinetic energy. The kinetic energy will never be bigger than the potential energy. It's only going to have as much energy as we gave it when we pull it up here from the center. It works every time, unless you give it a push or something. Oh, sorry.
Energy can be changed from one form to another.
Electricity is a form of energy. You're using some right now. But do you know where electricity comes from? Do you? Oh, come on! A lot of it comes from the heat released by burning coal. The coal makes heat. The heat makes steam. And the steam is running this small turbine. The turbine is actually an electrical generator. And we can read the electricity on this gauge. This is the same way it works in a real coal plant. Except there's more coal, more steam, bigger generators, and more electricity. We can use the energy of falling water to make electricity. The falling water spins a giant turbine. It's like a big paddle wheel. And that runs an electric generator that makes electricity so you can watch the show.
Okay, so let's back to the lesson. Now, in your notes, you learned that 1.4. Okay, let's look at the notes there. 1.4. All right. You should be by now be able to fill up the answers for the forms of energy. All right. Under mechanical energy, you should be able to get some potential energy. For example, but some sources of potential energy. Sorry, not sources. Forms. Gravitational potential energy, elastic potential energy, chemical energy. Alright, under kinetic energy over here, you have kinetic energy. The non-mechanical energy could be heat energy, light energy, sound energy, and nuclear energy. Okay, now, as you can see from the video just now, energy can be converted from one form to another. This is a very crucial and important concept. Okay, so there are a few examples here of a car, okay, where the petrol that is being pumped into the car is the chemical energy, chemical potential energy. And when you burn the fuel in the car starts to move. That would therefore be kinetic energy. Now, of course, when you start the engine and when the engine is moving, okay, and is moving, you will be able to hear the sound of the engine due to the grinding parts, and you can also feel the motor of the engine is actually very warm. All right, there is heat being generated when you burn the fuel in the engine. So, what do you think? Let's have a look here. Which of the three energy forms of energy here, which one is useful, which two are wasted?